start again. So basically there are various forms of functions. They come in different ways, right? We have algebraic function, right? They just come like algebra themselves, right? As a basic algebra themselves, right? Something like how do I clear it, right? Let's say f of x equals to s squared plus 3. So generally this is one form. So this one I call them algebraic functions. There are other ones that contain logarithmic functions. So let's say f of x, they contain log x, for example. This is a logarithmic function. And then we also have exponential. Yeah, exponential. So I have f of x equals to e to the power, let's say 3s squared. So I don't think, no, I think it's left with 1. Okay, let's try these ones first. These are the, no, and there's how do you call it? Trig functions. The trig functions. Trigonometric function. Yeah, but I'm coming. Before you go to the trigonometric function, let's do this. We are going to differentiate these things, right? One after the other. So it's a very basic. I'm just testing. For the first one, what's the answer? I mean, let me give this one log s squared. For the first one, let me go to this thing. Give me the answer. How do you call it? Oh, Marinos. Yeah, 2x. 2x. Yeah. So the answer for this one is 2x. Fine. Now the next one, Stella. The log. Yeah, the log one. Log of s squared. I think. No, I don't have any idea. Okay, Marinos, what do you have? I feel like it should be. It should be two log x. 2 log x. 2 log x. All right, no, that's not it. That's not it. So these are the things I'm checking. So no worry. Let me just take you through. Let me just do the logarithmic one. So if you have a log function, so let log of f of x. So the differential, if you are differentiating a log function, is just you do f prime over original function. This is what you do whenever you meet any log. Yes. Can you hear me? Yeah. Excuse me, please. Francis. Yes. So the log is the same as the in? Yes. So ln is log to the base e. Okay. So it's the same thing. So let's go back. Since you now remember. So Marinos, can you do this thing for me? So I said it's generally f prime over the original function. So okay. The log doesn't appear after the differentiation. So we go to Marinos. Marinos, try. What's the answer again? Oh no, this is Stella. Sorry. The E1. No, we are here. We are here on the second one. The log one is log. It's 2x over x to the power 2. So s squared. So it is what? What's the final answer? The final answer is 2 over x. Yeah, that's 2 over x. Okay, so we are just doing quick checkup. We haven't started the main work. The next one is the exponential. Marinos, you know how to differentiate exponential functions? No, not really. Stella, do you know how to do it?
Yes.
So if you have e to the power f of x, what's the answer? After differentiation, what do you get?
It's f prime of x e to the power f of x.
Yeah, the same function again, f prime. Almost similar to the logarithmic one. So based on that, based on this, I want you to give me, I think it's Marinos as its next. But then, yeah, so if we have e to the power 3s squared, so our f is 3s squared. So basically, it become, we said it is f prime e to the power f. So we keep the function again. So if you have this, what are you going to have? Stella, what are you going to have?
We're going to have 6x e to the power 3x squared.
3s squared. Why not we get it?
Yeah.
Yeah. So what these are the thing you have to know this. Okay. So for now we are going to exponential. I mean trigonometric. For trigonometric functions, their basic ones are sine, cos, tan. These are the basic one. Then you go to the cotangent and all that. But I'm going to do this basic stuff. I'm just checking the basic stuff. So if we differentiate a sine, what do you have?
Cos.
You said?
Cos.
If you differentiate a sine, you get a cos. If you differentiate a cos, you get what?
Negative sign.
If you differentiate negative sine, you get what?
If you what?
If you differentiate a negative sign, what do you get?
You get a negative cos.
If you differentiate negative cos, you get what?
A positive sign.
Alright. So this is the map that I gave I think the 27th. Yeah. The map to do this differentiation. It's just like cardinal point. The straight line, the vertical line is the trigonometric. It is a sign. So it's just like cardinal point. You have positive and negative. So the top is positive sign, the down is negative sign. And then for the horizontal line, we have cos here and negative cos over here. Are we okay?
Yeah.
I think there's a noise somewhere. So this is what I give them. So if you are doing differentiation, you go in this order. You go in the clockwise order. You go in the clockwise order like this. If you go like this, you are doing differentiation. But if you go like this, you are doing integration. So if you integrate a sign, you should get a negative cos. If you integrate a negative cos, you get a negative sign like that. You get the map?
Yeah.
Yeah, no need to show this. Now the next thing is, now let's go to, if you have a cos 3x, cos of 3x. So, or let me not do that. Let me put the general function. Let's say f cos f is a function. What's the resulting answer?
The differential of the function.
So f prime plus whatever you get from this map, right? Right. So it's going to be f prime, but then the cos becomes, we say cos, if you are differentiating, cos becomes what?
Negative sign.
Okay. So because it's coming with negative, I would do negative sign. The function still comes back f. You don't change the function. These are the basic things. So the actual thing will be negative f prime If you already know that it will give you a negative something, let's put a negative at the front and sign of f. By that, you'll be able to save yourself time. So these are the um, simple ways of um, I want to clean everything. I'm coming. Okay. So now, I hope we are good so far.
Yes.
So what we are doing is just revision. Now, we are going to start the actual thing like substitution. Substitution method. So now, for substitution method, all you have to know is that it handles functions that multiplies like multiplication. It's actually kind of handles multiplications. Or another way of saying it is if it's not multiplying, you will see the functions um, carrying a power. The function is carrying a power. If you are integrating a function that is carrying a power, then that will be it's likely you use substitution. So these are the signs. So if you have something like this, 3x plus 2 all to the power 5, this one is likely going to be a substitution because you are integrating a function that is raised to a power. Or another way of having it is you'll be seeing a function 3x plus 2 multiplying 3x minus 5, something like this. So two functions are multiplying, right? So that's what will tell you that it will just give you a clue that it's going to be a substitution. It's a clue, but then it doesn't mean you have to confirm first. There's a way to confirm so that you don't waste time solving using substitution alone. Right? But this is a general thing. When you see something like this raised to a power, your mind should go like you are going to be doing substitution method. Are we fine?
Yeah.
Or when they are multiplying. All right. So when I say carrying a power, this one is also inside. You are integrating square root of x minus 5. So you know that the square root is the same as x minus 5 all to the power half. So it's carrying a power other than 1. That's is the same thing. So if you see things like this, it will give you a clue of substitution. And most of the functions are basically they are mostly, how do you call it? They are mostly algebraic functions, right? Other ones you can see is exponential function to the power 3x, for example. Hello. Someone is making noise in the background. Hello.
Hello. Yes.
Can you be at a safe place where there's who is that? Oh, Marinos, is it you? There's a noise over there.
What did you want to take it?
Can see there. All right. So this is the thing that we'll have. So for exponential functions too, you have to see something like this. Exponential functions also, if you're integrating them, they may give you a clue of a clue of whether you are going to do exponential substitution or by parts. But then if you come to by part, generally there are two functions multiplying, all right. But then the functions are of different types. So you can have like x e to the power 3x. You see that x alone is an algebra, but then the other one is an exponential function. So you can see for by parts, you should see maybe a log multiplying an algebra, or you'll be seeing a trig multiplying a log, or so the functions are of different types. Are we good?
Yeah.
Yeah. Is Stella there?
Yes, I'm here.
Yeah. So that's the general picture that you have. So when you see something that is of the type two different functions multiplying each other, you should have a clue that it may be a by parts, but then it's always not sure. The very first thing to check is check if substitution, because substitution can work for both something that looks like is substitution and something that looks like it is by parts. So the first thing to check is substitution. But how do I know that I need to do substitution? Because they all look the same. So what you need to do is that, let me start with the first example. First example, I think I need to clean some stuff, or let me just continue. So let's work with a simple example. Let's say I'm differentiating 3x plus 4 all to the power 2 dx. So looking at this function, I will know that it's going to be substitution. Because what you have to know, take in mind is that if you have a simple function, one single function, and it is raised to the power without any other thing multiplying it, what you have to keep in mind is that try to differentiate what is inside. Try to differentiate what is inside. If you differentiate it and what's inside gives you just a constant, then you have to proceed with substitution. Again, when you have a function, you are integrating a function raised to the power 2 or raised to a power. What you have to focus is that take what is inside that function, the thing that is raised to a power, the whole function is raised to a power. Try to how do you call it? Differentiate it. So what I have inside is 3x plus 4. And 3x plus 4, if I differentiate 3x plus 4, I'm going to get what? 3. Yeah. So 3 is a constant. If 3 is a constant, then you need to proceed with substitution. That's a,
Okay.
I believe you know how to do substitution yourself.
Yes.
Marinos, is that the case?
Yeah, I'm okay. I'm okay with substituting.
Okay. So that's how you one way of finding it. But if I give you something like this, 3x squared. If you differentiate what is inside here, you are going to have what?
6x.
6x. Do you think substitution will work for this case?
No.
Yeah, 6x is not a constant. What you're supposed to do should be a constant. 6x is not a constant, so substitution will not work. This one will go and we will do something called trigonometric integration, trigonometric like method substitution. So it's trigonometric substitution that is useful for this case. But I believe you haven't reached there yet. But then all the questions, so if you look at that, the question I gave first, the one I gave first, for example, this one, you can see, will substitution work for this one?
Yes.
Why?
Because when you differentiate it, you get a constant.
Yeah, if you differentiate because a constant, because it's standing alone. All right, now let's go to the second scenario, other scenario. So we understand that this particular one will not work, right?
Yes.
Marinos, why? Marinos, why? Marinos, why will it not work?
Because for substitution, you have to get a constant after differentiating.
Yeah. So now let's look at the other case where I have x minus 1 multiplying x plus 3. So someone is going to ask if substitution will work. This one is simple, right? It's just simple multiplication. What you do is that you just expand. You expand and then you differentiate. But then that may not be the case all the time. They will give you something like, let's say, raised to the power 3. And you want to see if substitution will work. So there are two functions multiplying. Two functions are multiplying, and then one is raised to the power 3. So whenever there is multiplication, you need to try to do substitution. And then what you have to focus on is you take each of the functions. You see if you differentiate the other, what you will get. Will it be able to cancel the other one? So if this is one function, this is another function 2. So you can take, like, let's take number 1. If you differentiate this guy, what you get, it should be able to cancel this one. That's when you will know. So if you take the first one, you differentiate it, you get 1. That one cannot cancel this guy, s plus 3 all to the power 3.
Okay.
Yeah. Then you go to the second case. If you differentiate this one, you get 1. 1 cannot cancel this. It cannot happen. So that particular method, we cannot do substitution for it. Are we good? Now I have a nice example here that I want to show. I'm integrating. It gives me s cubed plus x to multiply 3s squared plus 1. And then the s cubed is raised to the power 5. This is an example from a textbook. Now they are just saying, they say differentiate. So here there are 2 functions. This is function 1 and this is function 2. So if you look at it, I will take function 1, I will differentiate it. What will I get?
3x squared plus 1.
So it give me 3x squared plus 1. At once, now I know that this one can be able to cancel this completely, right?
Yes.
Yeah, so that will give you a clue that, okay, this method is a substitution method. So how do we go? The one that you differentiated, you make it like u equals to that function. U is equal to s cubed plus x. Let me solve this one fully. So if you die, I need to find du over dx. That will give me 3s squared plus 1. Now I need to make the s the subject. So the x is equal to du over 3s squared plus 1. Then I need to put that inside the equation. So I know, let me just clean this side. And I already made, I said that this one, so it's going to be integral of u is what? U. I say s cubed plus x is already u. Is going to multiply 3s squared plus 1. And I already find dx. And I say dx is equal to du over 3s squared plus 1. So I'm going to go here. Let me clean this side to just save space. Then I know my ds. The ds is what I made a subject. So I come and copy ds here. I say ds is equal to du over 3s squared plus 1. So you see that this and this will cancel. So this cancel this. At the end of the day, I just have u du. But then u was raised to the power 5, right? Do you remember?
Yes.
Yeah, raised to the power 5. So this is what you finally have. Then you can proceed from here. So you can see that at the end of the day, there's some cancellation. That's why when you look at the question, so me, if I look at this question, I will be able to quickly tell what method to use. I hope you can now.
Yes, please.
All right. So if, let's say, so this one, the next one I'm going to give you, you just tell me whether it's going to be, substitution is going to be possible or not. So I gave you, the next example they have in the textbook here is 2x plus 1 ds. Will substitution be possible, Stella?
No.
Okay, why do you think so?
1, there will be nothing to cancel out. So if we present u with something, like even if you differentiate and you put dx there, you don't have anything to cancel out.
What do you think, as Marinos?
Yeah, I think substitution can be possible.
You said?
I think substitution can be possible.
Why?
Because first, we said if we differentiate the function, we get a constant, and also this is a function to the power of half.
Yes, this is a function to a power of half. Yeah. Substitution is possible. It's a power half. So Stella, I just brought the first question. Hmm?
Okay.
Yeah, so this is a function to a power. So if a function to a power is not two things multiplying, see the difference. See the difference. So if you differentiate what is inside here, you have a constant of 2. So it's possible.
Okay. I was thinking because there's nothing to cancel out.
The nothing to cancel out. We said that, see when you are talking about cancellation, when two functions are multiplying, two different functions are multiplying. The first case was when the function is just raised to a power. You have to differentiate to get a constant.
Yeah.
You need to follow. Are you following though?
Yeah, I'm following.
Yeah. So it's the same thing. So I just check the first concept. This is the first concept. Oh,
Okay.
yeah. So let me see the next question to try before we move on. Um, um, oh, the ones they are giving are all okay. So, hmm, we'll do the same. It's possible to do the same things for trigonometric functions as well, or exponential functions. So when they give you a cos 7x plus 3 dx. Then they ask us to integrate this. They ask us to integrate this. So this one to substitution method will be possible because the function trigonometric function also use the same concept. What you have here, if you differentiate it, you should have a constant. We are having a constant, right?
Yes.
That will be 7. So what will happen is that then, since it will give you a constant and there's nothing at the other side to cancel, so what will happen is that, so what you have to notice is that if the functions are not multiplying, there's always a 1 year. There's always a 1 year. At the end of the day, we are looking at getting a constant. So, how do I explain this one to you? Okay, yeah, let me just continue. So this one will give you 7. So if it will give you 7, then u will be equal to 7x plus 3. Then you do the substitution and do the blah 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 until you get your final answer. Are we good? Or do you want me to solve this one?
No.
All right. All right. So now let me look at another question. So now this is another question that says we have to integrate s squared e to the power s cubed dx. So this is a case of two functions multiplying. You might think that this is by parts, but this is not by parts thing. Why do you think so?
You said
Which method are we going to use for this? Substitution or by parts?
I think you can use substitution.
So the first check, okay, why do you think that we can use substitution?
So if you differentiate the x cube, you get 3x squared. So that can cancel the x squared in front of the e out.
Yes, it's true. That's how it works. I hope you are seeing the trend now.
Yes.
So if you differentiate this one, the e1, you will get 3s squared. So the one that is here, if you do s squared over 3s squared, you will simplify it, you get 1 over 3. So it's a constant. Then we can proceed with, so then you can say that u is equal to s cube. Then you proceed with your substitution. Marinos, are you there? You said Yeah, so when we are having exponential functions, when you're having exponential functions like this one, so we multiplying for exponential function, what happens is that you focus on each power here, right? And this. So you multiply when you differentiate this one, you have 3x squared. When you differentiate that one here, you have 3x squared, right?
Yeah.
So now whatever you differentiate, make sure that it can cancel the other one, the other function. So you have x squared, which is here, divided by 3x squared. If you do this, this will cancel this. It will left with 1 over 3.
Yeah. Yeah.
So it's now as a constant. So that's how to do substitution. I will now give you sample this thing, then you tell me. Um, okay. So now I'm going to a special case of, so do you have x to multiply square root of 2x plus 1 dx. Do you think substitution is going to work? Hello? Are you guys there?
Yeah. Um, from the previous one, I think substitution works because if you differentiate in the bracket, you get like constant also up to a power.
Okay, what case is this one? What case is this? Is it one function raised to a power or functions multiplying?
Two functions multiplying.
If it is two functions multiplying, what's the case? What is the rule for it to be substitution?
They would have to cancel out, but this one they can't cancel out.
Yes. So why were you saying that it? But you were saying it will work.
I said I think it will work, but then when I solved it, I saw it's not working.
All right. So here's another special case, right? Where two of them are multiplying, right? And then, so what we do is that um we are going to take the one that is actually in power, right? This guy. If you differentiate this guy, you are going to get 2, and 2 cannot cancel this guy. So there's an issue. But there is an a step forward that you need to check quickly, is that if you do um if you say u equals to 2x plus 1, then you know this one will mean that what will be the value for x? X will be equal to u minus 1 all over 2. Are you okay?
Yeah. Yes.
So because s is kind of standing alone on its own over here. Also, because this guy is a linear, you need to be very careful. This guy is linear, and then the one here is also linear. So you need to be very careful when you are trying to go away from it. You need to be very, very careful. If it doesn't cancel out, in the case where it doesn't cancel out, you need to pause and wait and be very careful, because this is linear, this is also linear. Do you understand why I say they are linear?
Yes.
So basically, they carry the same degree. They have the same degree. They have the same degree. So you need to be very careful for such cases. For such cases, substitution will also work.
Yes.
For such cases, substitution will also, yes.
Okay.
Mm.
I thought you were talking. I couldn't hear anything.
All right. Stella, are you there?
Yeah, I'm here. Yeah, I'm also here.
Is this step clear?
Hello.
Is this step clear to you guys?
Yeah, it is clear.
Hey, what about Stella? Stella is not talking.
Yeah, it's clear.
No, someone needs to check on Stella. Something is wrong with her.
No, I am here. I was just looking at the question. I substituted this one inside to see whether that one to work.
Okay. Did it work?
Yeah, when I substituted inside, I'm getting the function to be in terms of u. So I think we can integrate u and then put the u equals 2x plus 1 back inside.
Yeah, it will work. That's what I'm trying to show you that. Don't try to move away from it if it doesn't cancel immediately. All right?
Okay.
Yeah, that's what I mean. That if you check it quickly, that okay, if it doesn't cancel out, don't go away. Check if the two functions that are multiplying are all of the same degree. You know degree of a function, right?
Yes.
Okay, same degree. And if you can do substitution so that you have everything in terms of you. If you cannot, these are quick check. But then it will be it's very obvious. But for stuff like this, and also this one cannot be by part, because for by part you need to have two functions of different types. You cannot go to
Okay.
bypass. You cannot go to bypass. It's two functions of different types. These are algebra times algebra, like algebraic function times algebraic function. You understand?
Yes.
Okay. So that's for that. Let me try to give another question. Um. So if this is how to quickly analyze those stuff. Trigonometric one, I think they will do trigonometric substitution also later. But right now, the next one I'm coming to give you are just questions. So it's time to solve questions. I'll give each of you one, then you solve it. When you solve it, then you go to by part and look into by part. So
Okay.
what you tell me is that you tell me whether substitution is going to work or not, and if it is possible, why? Are we good?
Okay.
All right.
Yeah.
So I'm going to Marinos. I will not put the integral sign. So I just put it there. This is for Marinos. 2x plus 4 to the power 5 dx minus this particular thing. Let me just put it so that you don't confuse. Yeah. Will substitution work? And why?
Yes, it work. It
Why?
work because when you differentiate the inner function, you get 2, and that 2 can also cancel the 2 outside, so you get maybe u to the power 5. Then you integrate that one. Then it has back.
Yeah, that's correct. Um, I'm looking for someone to catch. I don't know why my next question has fallen on this one. But then 1 minus r cube dr. Stella, let me quickly.
Yes, I'm coming.
All right.
Okay. So I think substitution will work
Why?
because when you differentiate, if you let u equals 1 minus r to the power 3, if you differentiate, you get negative 3 r to the power 2. So if you do the dx and you put that there, it can cancel out the 9 r to the power 2.
Yeah, correct. All right. Um, I'm going to um where is I'm going to Marinos next. Marinos, are you ready for me?
Yes.
All right. So for you, let me see. I don't want to give you these things are simple because now you guys understand the concept. So I'm afraid. So I have x cos x dx minus.
Yes. Yeah, you can use substitution.
Okay, why? This is what case? What case is this one? Is it what, single function or two functions multiplying?
Two functions multiplying.
If two functions are multiplying, what's the rule?
It should cancel out.
So why are you saying that it will work? Which one is cancelling out? I don't get it.
Yeah, I just wanted to do it.
You said,
I just wanted to do it.
hey, it won't work. Stella, come and defend us.
Okay. So if you it won't work because if you even let x equals to you will still have u cos u.
Yeah. Actually, the truth is that it will not work. It will not work. So if it's not work, will you go to by part or you go to trigonometry?
You go to by part.
Why are
I
you
think
going to
by
by?
part can
Why are you
solve
going to
this
by part?
because there are two different functions of each like kinds. The
Yes.
x is for linear and then the cos x is trigonometric function.
Very good. Very good. That's it. We are done for today. Have I achieved my goal?
Yes. Yes.
Let me give some questions again. What about this? This one, x squared e to the power x. This is for Marinos. Oh, the one for x e to the power x. This is for Stella, and then x squared e. No, this is coming from my head. Oh, x squared ds. This is for everybody. Everybody will explain their reasoning. Okay, so let me bring it down. Marinos, Stella, whoever is ready should talk.
Yeah, we should solve it or we should explain why
Oh no,
what can be used and why this.
me, I believe you can solve. Oh. Yeah, it's not about solving. If you don't know the
Okay.
road, if you don't know the road,
Okay, so
how will you even start?
there's my own substitution no way because we are dealing with two functions which are not they are of different kind. One is exponential, one is linear or algebraic or something like that.
Hey,
Then
okay, continue. You say they are laughing at you.
okay, they are of different the function of different.
It's
The
not.
function of different
It's
things.
not because no. It's not because they are of different kind. Masa. That's not it.
Okay, because when we differentiate we can't cancel out and they are two functions multiplying.
Stella, what do you think about his own?
You said?
What do you think?
Yeah, it's true.
I'm interested in the reason. It's true, it's not work, but I'm interested in the reason.
The reason why,
Mm,
if you use, if you represent you even by x squared and you differentiate, it still won't cancel. It won't have anything to cancel out.
all right. Okay, Stella, your own.
And my own too is not of substitution. I think it's by parts.
I'm interested in the reason.
Because if you represent u with x, you get du equals dx, and you end up with u integral of u e to the power u. So it's the same thing like the x. So unless you use by parts.
Okay, the last one. The last one. I said
The last
it's for everybody.
the last one too is by parts.
All right. Marinos, what do you think?
Yeah, by parts.
Hey, you people, you fail my small, simple exam. You people are telling me the last one is by part. How?
You see?
Are you guys telling me that this is by part? This was here.
Which one? No, that
Hello.
Hello.
Are you,
Yeah, when
is by substitution. You can represent u
by
with
x
x
square, x
squared.
square.
so then what happened first? Why are you guys telling me it's possible? It's not possible.
We overlook that fact.
Now it's like you know the thing now, so you are rushing it.
No.
All right. Let everybody tell me their version of the understanding of the whole thing so that we go. So Stella, take the substitution part, and then take Marinos, you take the uh, bypass part.
I'll take it.
Then we are done. Stella, start.
So, so for the substitution, the notes I took were that the functions have powers or they are raised to powers, or they'll either be multiplying. So when a function is raised to a power, you can use substitution. And then for the multiplication part, you check whether when you differentiate one, you can use it to cancel out the other. If so, then you can use by substitution.
Hey, wait, you say the power one was?
For the power, you when the functions are raised to like a power, you can check whether you can use substitution.
How do you check? What tells you if a function is raised to a power, does that mean that it is going to substitution?
Mm, yes.
If a function is raised to a power, does it mean that it's substitution?
Doesn't mean it's substitution.
Mm-hmm.
If a function is raised to a power and then you differentiate the function itself and you get the constant, it means you can use substitution.
Now you are talking. Mm-hmm. And then for the multiplying one, what?
For the multiplying one, then the multiplying one mostly they are like of the same, like let's say type, like the same kind of function. And then when you differentiate, if you use like maybe u to represent one and differentiate it, you can use like the differential to cancel out the other function.
All right. Marinos, your turn.
Okay, so for by parts, the first you see that there are two functions multiplying, and they are of different type. So one can be, let's say, x, and the other one will be, let's say, exponential function. So for that one, if you differentiate one, you'll not be able to cancel the other one. So you will use by part.
All right. All right. Guys, bye bye. I'm eating.
Is that
Oh no, report, right? Report.
Report of the day.
Yeah, report of the day, of course.
okay?
Okay.